Okay, so the last part of 4.1 is section 8, which talks about linear and angular speed. So it says, suppose an object travels around a circle of radius r. If the object travels through an angle of theta radians and has an arc length s in time t, then the first formula it gives us there is for our linear speed. Now remember, speed is also known as velocity. Now, so for linear speed, we're not going to use the symbol that they use right there because it looks too much like my theta. So I'm going to use a Greek letter nu, which looks like a V, and that's equal to our arc length over time. The second formula there they give us is for angular speed, or velocity. And its formula is omega, which looks like a W, is equal to theta over time. So, how do you tell the difference when they're giving you something in the problem on whether it's angular velocity or angular speed, versus linear speed? The easiest way for me is to tell you is to look for the units, because linear velocity is arc length over time. When you look at it, it's a length measurement over some form of time will be its units. Angular speed is going to be some type of an angle measurement on top and time on bottom. And so that's usually the easiest. So if you see it's feet per minute, you know it's linear speed. If you see it's revolutions per hour, then you know it's angular. Or, radians per minute, whichever, it's going to be angular speed. So just watch the units to help guide you through it. Now, we can take both of these, and there is a relationship between them, because we know that linear speed is equal to our arc length over time, and we know from earlier in the lesson that arc length is r times theta, and so it's over time. And if we take that theta over time, we see right above there that that's equal to omega. So our linear velocity is equal to the radius times the angular velocity. And so watch for that, because you're going to end up using that one quite a bit in some of the word problems that are dealing with the velocities. Alright, so now that we got that, let's go on then to example 1. So example 1 says, a model plane is attached to a swivel so that it flies in a circular path at the end of a 12-foot wire at the rate of 15 revolutions per minute. Find the angular speed and the linear speed of the plane. Alright, so it told us here that the plane is attached to a swivel and flies a circular path at the end of a 12-foot wire. So that 12-foot wire is our radius. And it's at the rate of 15 revolutions per minute. Well, do you see that revolutions? That's an angle measurement per minute. So that's going to give us omega. So omega, our angular velocity, is going to be 15 revolutions per minute. Now, the directions doesn't really tell us when it says the angular speed what kind of units it wants us in. So we could say that is our angular speed, but in order to put it in to help us find the linear speed, we need it to be in radians, because remember, linear speed is equal to the arc length over time, originally up there in the formulas that I gave you. And arc length always has theta measured in radians, so we're going to have to convert this to radians. So what is a revolution? Well, a revolution is one full time around the circle. So if I want to convert from revolutions to radians, I need to get rid of that revolution. So I'm going to put one revolution on bottom. And if that's a complete circle in radians is our 2 pi. And even though we don't have to label it, I'm just going to put radians right there. Alright, so my units for revolutions cancels. So I got 15 times 2 pi over 1. So we end up with 30 pi radians per minute. So there's our angular velocity. And then it tells me to find linear speed as well. So remember that linear speed is equal to the radius times the angular velocity, or angular speed, and it's got to be in radians, which it is now. So this is going to be equal to the radius, which was 12, times that 30 pi. And so we work this out, and we get 1,130.973. And then for the units, remember it's going to be a length. So the length measurement we have here is feet per time, which is in minutes. And so this right here is our linear speed.